Preliminary exam chemistry paper 2022. Question 5 says the graph below shows the change in potential energy for the reaction where limestone is changed into lime. CaCO3 becomes CO plus CO2. Okay, we got potential energy here 420, 480, and the reaction coordinate. Is the forward reaction exothermic or endothermic? Now looking at this graph, we see there was no energy, and later on we see that the energy is gone higher than the zero energy. It's gone to 4, it became 420 at the end. So it's basically an endothermic reaction. Question 5. Five. 0.1. This is for the actual exothermic or endothermic. So we absorb energy 5.1.1. So it's an endothermic reaction. So it's endothermic. Next question. Calculate the heat of the reaction for the forward reaction. So if you say that the delta H, if you look at it, basically will be 420 because it was 0, it becomes 420. But it's 2 marks, maybe you can say 420, but if we have to calculate it, we can say for 5.1.2 will be your change in your heat is equals to the energy of the products minus the energy of the reactants. So the energy of the products we see is 420, and the energy of the reactants at the beginning was 0. So basically here the answer is 420, but then we must put in a unit. So the unit that we will use is the unit that's given here, kilojoules per mole. Kilojoules per mole, the energy of the kilojoules per mole. Kilojoules per mole. Kj dot m minus 1 kilojoules per mole. Okay, so that will be 5.1.2. The next question is write down the activation energy for the reverse reaction. So the reverse reaction will be from the back. If you go backwards, if you start here and if you go backwards and you go down this way, then the activation energy from the beginning to the highest peak here from 420 to 480 will be 60 kilojoules per mole. So that's what it will be, 60 kilojoules per mole. So it will be in this area. 5.1.3, 60 kilojoules per mole. Alright, so that's 5.1.3. Going further, there's another question. The following graph represents the number of particles against a specific amount of kinetic energy of the molecules, right? Kinetic energy of the molecules, number of particles. That's how they plotted. The data for samples R and S is obtained at different temperatures, which affect the rate of the reaction, right? So when will the rate of the reaction increase? This line here, T, what does the line T represent? It represents the point where all particles higher than this line T have sufficient energy for the reaction to take place. They can cause effective collisions for the reaction to take place. So whatever is above the line T. So in this area, these particles have sufficient kinetic energy for effective collisions to take place. Anyway, let's look at the questions. Define the term rate of reactions. Again, our definitions, don't forget 5.2.1. The change in concentration of a reactant. The change in concentration of reactants or products per unit time. Okay, so that is the definition of 5.2.1. What does the area to the right of angle T represents? So we just mentioned it, the right of the area. They are particles that have sufficient kinetic energy for effective collisions to take place. Alright, so we can write it down. 5.2.1. The number of particles that have sufficient energy for right, we can write something like that. 5.2.2. Which sample was at a higher temperature? Write down only sample R or sample S. So if you look at this two, sample R goes like this, is the graph that's here. So after T, it has less particles in the area for effective collisions to take place, and S we see that it is higher. So S is higher, so basically S will be at a higher temperature because there's more to the area below the graph after T is greater with S rather than R. So we sample as a higher temperature, it will be S. No? So we can write down 5.2.3, 5.2.3 sample S. 5.2.4. Explain your answer to question 5.2.3 by using the collision theory. So talk about effective collisions, right? So we can say 5.2.4, 5.2.4. We can say that when temperature is increased, the particles gain energy. So therefore more, we can say, particles will have sufficient energy for effective collisions to occur. So more effective collisions will take place. Okay, something to that effect, 5.2.